Seasons within the concave Earth. I animated the sun oscillating around the celestial sphere every 6 months. So when it's in the Tropic of Cancer, you'll notice that you get 24 hours of daylight at the North Pole and 24 hours of darkness on the South Pole. And conversely, when the sun is in the south, you'll see that you will get 24 hours of daylight on the South Pole and 24 hours of darkness on the North Pole. Originally, when I animated the sun, I did it linearly. There was no acceleration or deceleration, so I couldn't get the equinoxes to line up on March 21st or September 21st. However, when I added acceleration and deceleration, so it's decelerating at the extremes like that, the equinoxes lined up perfectly. And so in nature, you can conclude too that if something is orbiting around something magnetically and it's oscillating north and south like that, there's going to be acceleration and deceleration. In a heliocentric model, you have to conclude that the Earth is orbiting around the sun in an elliptical path. This is very unnatural. You also have to conclude that it's tilting. You have problems with that too as well. And you also have to conclude that it's precessing or wobbling, because it shows that after a year the sun is in a different location against the stars. But if you understand within the concave Earth, it's all taken care of simply by the fact that there's two different velocities. The velocity of the sun and the velocity of the celestial sphere, which is slightly faster than the sun. A sidereal year or a sidereal day is 4 minutes faster than the sun. So after a full year's time, the sun is simply just going to be 1/70th of a degree in a different location than the year before. The planets are all magnetically affected by the sun. So when the sun is inclined like that, the ecliptic of the planets, that magnetic ecliptic imaginary path, is going to be influenced by it as well. There's a real retrograde motion to the planet. It's not just an apparent retrograde motion caused by a supposed spinning Earth. It's simply the fact that when the planets go behind the celestial sphere opposite the sun, they're going to get confused magnetically. So they're going to go the other way for a little bit until they catch up with the sun's influence again, and then go the same way that they were going before. Mercury and Venus, they're going to be orbiting the sun. So when they go behind the sun, they're going to get confused as well. So that's how retrograde happens within the concave Earth. The Milky Way band, it's a band, it's not a spiral galaxy. It's actually a literal band that separates the celestial sphere into two different hemispheres, two different magnetically influenced hemispheres that actually steer the sun. So the Milky Way band has a function. So when the sun crosses that galactic plane every 6 months, it's also exhibited by the Ulysses satellite. They show that every 6 months the sun is oscillating back and forth. So when it crosses that plane, it steers the sun in the other direction. Like when it's up north like that, it's going to steer the sun south, and then conversely the same when it goes down south. When the sun goes down south, when it crosses that plane, it's going to steer the sun back up north. So it's all being influenced by that dividing line, that Milky Way dividing line. It has a purpose, it has a function. Everything works within the concave Earth. Sunlight is bending around the inside of the Earth. That's how we get lunar eclipses. There's an opposite funnel-shaped void area opposite the sun. When the moon goes through that void area, it gets eclipsed. North or south of that void area, it's just simply going to be a full moon. So everything works in the concave Earth. You've seen my animation here, I made it a wide angle, so I wanted to include everything, so that's why it kind of looks kind of funky, but it's Occam's razor. The simplest answer is always the best answer. So. That's because the plane is between the sunlight and the cloud. Flat earthers don't understand, as well as convex earthers, they don't understand that light bends. I didn't explain why they clipped, I'm going to do that now. So the sunlight is being bent around, and it's being dispersed through the glass sky, and it's being projected, okay? It gets dispersed, it gets polarized. So going into illustrate it here. I made another graphic showing, okay, so here's the sun here. It's approaching sunset. Let's say it's 4 o'clock, 5 o'clock in the afternoon. And it projects different, let's say, different columns of light from wherever you are, whatever vantage point you are. Let's say, like if you're over here, you're going to see the sun ring, the direct sun. right over there. So if you're way over here, more extreme to the sun, you are going to see the rainbow or the sunbow. It's actually called this. It's really a sunbow. When you are in between the clouds and the sunlight, right? So the reason why you're only seeing a partial bow is because the sunlight comes around. It cannot bend enough at ground level, so it gets clipped like that. However, if you rise up higher, let's say in an airplane at that same vertical height, you will see the full sunbow. So if you're in an airplane, you've seen this before, pictures of this. It projects the shadow of the plane, and there's a rainbow or a glory or a sunbow circling the shadow of the plane. SR-71 is going to tilt 8 degrees nose up. You're going at Mach 3. The faster you go with a plane inside the Earth, you're going to have to tilt that up more. Now that would make no sense whatsoever if you're trying to eliminate drag. You would want to tilt it down. You would want to get it as level as possible, but you're simply running out of real estate. So they're hiding this information from you. It's the pact. It's the pilot pact. It's the AAPP, the Australian Aviation Pilot Pact, or the American Aviation Pilot Pact. Never a straight answer. Oh, is it the fuselage that's tilting up, or is it the wings that are tilting up? Is the Concorde nosing down the faster it goes, or is it tilting up the faster it goes? Documentation would show that it's tilting up the faster you go. Welcome to Cellular Earth Reality. Thanks for watching.
The lift force cohabitates with the centrifugal sink force, which has the inverse proportion effect. The sink force is the ether push force we all experience on the Earth, or in the Earth. As it moves, the divergent fluxes put the brakes on the Earth, preventing any rotation. Remember Wheeler's gyroscope on his huge neodymium iron-borne magnet? The centripetal lift force perpetuated the magnet in a viscous free flux near the center. Yet the centrifugal divergent sink force stopped the gyro on the edge. That's what's happening with the Earth.
Coma aberration. Let's take a look at coma aberration. This guy is actually shining a light source through a glass lens, and the angle of the incident light source, it's an off-axis angle. It's going to be an oblique angle, so it's going to create an aberration on the screen here.
The image, and it's away from the optical image.
Let's see him tilt it. Oh look, he's going to tilt it now. What's happening? Look at that. Right there, you see that? That's called coma. It actually has a term in photography. It's called coma. Coma, or chromatic aberration. It creates a tail. Chromatic aberration. It's an off-axis focal point. So it's creating a tail. Just coma is named for its comet-like shape. Well, actually, the etymology for the word comet actually is derived from dust, so it's completely wrong in the first place. But in photography, chromatic aberration is definitely an effect created by the glass. More pictures here. Comet Catalina. You got 3 tails here. Here's one with 3 tails. So we got some tangential stigmatism with some coma aberration. Here's more video where I was explaining the comet tail splitting. Now with the sun here on the top and the light, actually it's going to be radiating around, bending around like that. The sunlight can either be coming through the lower glass and going back up again to create the splitting, the coma aberration effect.
The octahedral part of the crystal field theory tells us that an octahedron is formed from the three cardinal axes. So we have the third dimension here. An octahedral is a product of the third dimension. And what we have is the X, Y, and Z axes, Z being vertical like that. They talk about having 6 negatively charged ligands, they call them. And so these ligands are on the corners of the octahedron like that. In the center is a positively charged atom that they call a cation. And what they tell you is that the ligands, they converge toward the positively charged cation, and then they emerge, and it creates a sphere, a spherical energy bubble. Joe Parr mentioned a spherical energy bubble before. And so with that understanding, you can understand the foundations of the Earth, as recorded in Job chapter 38, like I've mentioned before in previous videos. And you could also understand the origin of heaven, the origin of life. It's right there. So I'll play that for you. And now we understand why we have a spherical Earth. We have a spherical celestial sphere. We have a spherical glass bubble in the sky. Actually, probably a couple of those. And it all has to do with the understanding of crystal field theory and product of the spherical energy bubble that is created by the convergence of the negatively charged ligands converging in the center. Also note is that the Libyan desert glass is a quartz crystal. So that's a really good indication that the glass up in the sky that fell down in the Libyan desert is part of the glass sky, part of the glass bubble, the glass sphere in the sky being a product of the octahedron. Play a little bit of this video here on YouTube where it explains it a little bit.
But when they all come together around a metal cation, they effectively form a spherical field around the metal.
So there you go. They form a spherical field around the metal, around the central cation. So that's a really good indication that the spheres are formulated from the octahedron, the foundations of the Earth, as I mentioned before. Once you have your foundations of the Earth correctly understood, everything else is built upon it properly. And then you understand you're living inside the cellular concave Earth. A little bit more here. And then within crystal field theory, there are actually orbitals where the electrons supposedly flow. And so they have 5 different orbitals here. We have the dz squared or z squared orbital going along the vertical z-axis. This one is actually distinct from the other 4 orbitals because it actually has a toroidal shape that's aligned with the x and y axis, and that's really interesting. I'll get into that later after I describe the other orbitals here. And we have the dx squared minus y squared orbital, which is aligned with the x and y axes as well, but going right along them like that instead of toroidal like the dz squared orbital. Those are the 2 main orbitals. The 3 inferior orbitals, I'll get to those, I'll show you those. This is the dxy orbital, but these orbitals are not aligned with the ligands, so they're going halfway between the ligands. And then you have the dxz orbital, and finally the dyx orbital, like that. But going back to the initial orbital, that actually is distinct from all the other orbitals because it has a toroidal shape in the center there. And now you can understand why we have an equator, why there's activity at the equator, that the northern hemisphere versus the southern hemisphere, there's like a reversal. There's a reversal of hurricane movement. There's a magnetic equilibrium that we can feel with Foucault's pendulum, for instance. The pendulum will not spin at the equator. And so with this understanding, that's why we have an equator in the first place, like that. And so this field that emanates out, it creates an equatorial equilibrium. That's why satellites can actually levitate at these cardinal corners of the base of the x and y's. And That's why we have the doldrums within the Earth. It all has to do with the understanding of crystal field theory, octahedral crystal field theory generating in equatorial region with the dz squared orbital. So that's understood. Everything is finally understood. Okay, the foundations of the Earth have been found. And you're living in the concave cellular Earth. You'll see over here, that little white dot is the sun, and so I got this sunglass sphere covering the sun, and then a wider moon glass sphere which has negative refraction covering the moon. And we also see how I, through optics and illusion, I created the inversion of curvature, and so we have this top-sided dome. It's going to be going down to the ground like that. I picked Norway as location, and the sky gets figuratively split in two, and so we see the arrows toward the 22nd and the 46th, and then we're going to see the actual inversion in just about a second here. Visual half of the sky inverts on the curvature. Okay, there it goes. Okay, and so from ground's point of view, because of the ice crystals that are, closer to Earth, it's going to pick up, it's going to create a canvas, a reflective canvas of the glass filtered light like that. And so that's why we get the 22nd over here. That's why we get the 46th. That's why we get the parhelix circle. I think it's the 100-kilometer glass sphere and the ice crystals in the sky that are picking up on that. And light is polarized, so we get the actual formation of what looks like to be an octahedron. That's just a little, it's just a little indication of what I've been telling you is true. And so that's what's happening, but the reversal is happening. I'm just going to go into Illustrator here. And what's happening when the sun goes out like that, also, that's, of course, we get the glass in front. That's why we get the bulge. That's why we get the stellar displacement. But anyway, we get a particular incident angle. I'm not really sure what it is. I haven't even bothered looking into it. But there's got to be a same angle in which the light is entering or leaving or passing through the glass, and both of them will create the spectrum like that. So we get the spectrum created because there's glass. It's close by, close to heaven. Okay, and so on this right side over here, you see the green line and the blue line. You have a shorter distance line for the green and longer for the blue. And so you'll notice that the green, somewhere in Earth, the sunlight's going to make a spectrum and halos, and well, both halos, 22nd and 46, are going to be created. And the red is going to be on the inside for both. So I put a little picture here indicating, showing you that 22nd degree halo, yep, the red's on the inside, and the 46, the red is on the inside like that. Okay. Okay, so that's what's going on there. But as we get further away, like toward when the sun is, getting closer to the horizon, we're going to get a flip. We're going to get a reversal with the secondary rainbow. So the double rainbow is going to be seen. The moon glass sphere planets, the moon glass and sun planet glass, and the moon glass 46th reverses on itself. And so that's what's happening. It's just a matter of distance. This guy really helped me out here.
We see the same spectrum that we started with, but with the colors now. We start with our screen close to the lens, and we see the same spectrum we saw before. Here is the light passing through the lens, and up above it we see the light that's sort of skipping the top of the lens. As we move our screen away, the colors begin to overlap until at one point we see a band of white light. Okay, we got a convergence of the white light, but then, watch this. As we continue to move the screen further away, we see the same spectrum that we started with, but with the colors now reversed. As we move the screen in this experiment, there's nothing to cause this change of color that we're... Okay, it's right there. You get a reversal farther away. And that's why we're getting the reversal in the sun and the moon glass sphere. Evidently, the sunlight is too close to the sun-planet glass sphere for that to reverse. It needs to be, the distance of that would need to be further away for that to reverse like that. Okay? But that explains... Did you get that? Let me see if you got that. I might have to play that again. I'm not really... It's hard working on a laptop here. Let me play that again. Experiment. There's nothing to cause this change of color that we're observing. The only thing that's changing is the overlap of the colors. So we can conclude that when we perceive this white light, what we're really seeing is a whole bunch of colors added together. Now, it turns out that you don't actually need all of these colors to trick your eyes into seeing white. If you're watching this on a TV screen or a computer screen at home, what you're seeing as white is actually a combination of red, blue, and green. But okay, let's go back. The direction that the colors were spread, the pattern was much wider than it should be based on the system geometry. We see the light that's sort of skipping the top of the lens.
Okay, so he's got a negative meniscus lens in front, and it's dividing the light like that. But also what it's doing, it's going to be converging it as he moves it further away.
The colors begin to overlap until at one point we see a band of white light.
Yep.
As we continue to move the screen further away,
Yep.
we see the same spectrum that we started
So we get the reversal right there.
with, but with the colors now reversed.
Okay, so that's exactly what's happening with the 22nd and the 46th degree halo, and the reason why we get a reversal in the double rainbow.
Explain the southern celestial clockwise rotation of the stars. Cellular Earth can. You cannot explain lunar eclipses. Cellular Earth can. I've explained that. I've explained how the light bends around and shows a clockwise rotation of the southern celestial stars. I showed how lunar eclipses happen when the sunlight bends around and converges and creates the Gegenschein and the moon exits the illumination zone. You cannot explain why the sun and moon touch and go beneath the horizon with a straight line paradigm. Actually, David Brinlin made a good animation showing that, where the moon would just simply stay up above the horizon, significantly above the horizon. You would just be doing cookies in the sky. You cannot give a working orbit of the planets. I can, obviously. I've shown you just right now in this video with the animation. Cannot explain the Gegenschein. You cannot explain where Megacryometeors come from. So you guys got major flaws to it.
This one that I pulled before, the sun at the top here is emanating the light and it is converging out the other side. Very similar to like if you look at a glass of water in the sunlight and you will see the caustic lines. They will converge the opposite side of the illumination, and that's what's happening. Initially I was researching this to find out, or to show you, to illustrate to you how the sun receives illumination. Now I said from both sides in the previous video, but this is just a cross section, so it's more than just both sides. It's really every side, every angle that the sun is wrapping around. It's illuminating the moon, so that's why we don't see the graduated shading of the moon. The front side is spherical, it's a half sphere, but we would normally see graduating shading on the moon, but we don't really see that, do we? And you look at a full moon, it's completely illuminated, it's flooded with light. And so that is why that is happening. And I was going to illustrate that, I was going to animate that. I did animate that. Let me just start this rendering here, but these contour lines are showing how the light is converging at this little convergence point. And I didn't even know they had a name for this. They call it the
Gegenschein.
Now,
Gegenschein.
it's very critical for you to understand why a lunar eclipse cannot work in a heliocentric model or a flat model either, but because the Gegenschein, it is a faint patch of light directly opposite the sun, the anti-solar point of the sun. They call it the Lagrangian point number 2. I can show you that over here. Let me get me out of the way here. The Lagrangian point number 2 here. See, this point here is opposite. This is a heliocentric model, of course, but here's the Earth. Now, think about this. Where do lunar eclipses happen? They happen at this Lagrangian point number 2. They happen exactly opposite. I mean, in a heliocentric model, they happen exactly opposite the sun, with the moon, with the Earth directly between the sun and the moon. You cannot, ladies and gentlemen, let me reiterate this for you. You cannot have a lunar eclipse in front of the
Gegenschein.
in a heliocentric model. They are mutually exclusive. The moon cannot be covered in Earth's shadow at a point where there is illumination. It's that simple. Do you understand what I'm saying? This
Gegenschein.
point is a bright spot, and that's where the lunar eclipse supposedly happens. This is a cross-section top-down. You can imagine this shape here of
apple. It's like an apple, basically, okay? So when the moon is in the apple, you know, the waxing, the first quarter, the waxing gibbous, the waning gibbous, the third quarter, even the full moon, it's still in the apple. When it leaves the apple, when it goes outside the apple, at the little butt of the apple, it doesn't get illuminated because it's not in this area of light, okay? Let me show you in 3D what I'm talking about here, okay? Here's a wireframe mode here. Okay, this is the moon. Remember I told you it's a half sphere. And so, a little bit hard to tell here with this wireframe, but here if I turn like that, you see how it's sticking itself out of the apple? And that's where it does not have the illumination, okay? Inside the apple, it's lit. Outside, it's not. And so here's
Gegenschein.
right here. This is illuminating. It's a convergent point where the light converges, okay? And I'll go back, I could show you how, this is a previous video I made, how lunar eclipses happen, okay? Here's the
Gegenschein.
I called it the darkness funnel. I didn't know it had a name for it, but it actually does. And so when the moon goes through, when it leaves the apple and sticks out in, you know, in front of the
Gegenschein.
It's going to be darker. It's going to be eclipsed. We'll go to the April 4th eclipse here. It's coming up here. Okay. Now, going back to what I said before, this point destroys heliocentrism. Type error. Some astronomers deny it even being there, but there is overwhelming, undeniable evidence. Okay? Undeniable evidence. Let me show you some research here.
Gegenschein.
Another mysterious phenomenon associated with the zodiacal light is known as, by its German appellation, the
Gegenschein.
It is said that in that point of the heavens directly opposite the sun, there is an elliptical patch of light. Now, I just told you I don't think it's elliptical. I think it's circular. I showed you how when you boost up the curves, it's circular. A few degrees in extent of such extreme faintness that it can be seen only by the most sensitive eyes under the best conditions and through the clearest atmosphere. This phenomenon seems so difficult to account for that its existence is sometimes doubted. Now, why do you think people would doubt that? Would doubt its existence? You know why, don't you? Because you cannot have a lunar eclipse in a heliocentric model. That's why they doubt its existence. Yet, the testimony is in its favor, is difficult to set aside. And look at this Wikipedia page on the
Gegenschein.
Look how weak, look how anemic it is. This is all they talk, this is all they have. If that is not a sign, if that is not indicative that they don't want people to know about the
Gegenschein,
because it destroys a lunar eclipse in a heliocentric model, then I don't know what is. Okay, this is all they say. But they have to admit that it's anti-solar.
Gegenschein.
It's German for countershine, a faint brightening of the night sky in the region of the anti-solar point.
Gegenschein.
Ladies and gentlemen. Now, the only way it works is within a concave Earth when the moon, like I said before, is leaving the apple zone of illumination. Okay? The moon is out here like that. It cannot be lit anymore because it's outside the zone. Okay? It's
Gegenschein.
It's like an inverted nipple. Okay? It's so for the most part, if you go from a top-down view here, for the most part, the moon stays within the apple. It only leaves the apple when it goes through the inverted nipple.
Gegenschein.
It's hard to say that, but that's what's happening. Now, I also talked before about I believe that the light that's emanating from the sun is vortexual, and so this
Gegenschein.
This darkness funnel, it actually will fluctuate north and south. That's why we only get lunar eclipses during the equinoxes, during early April or late September. And let's go back here in After Effects here and play with the moon here. So you take this moon, oops, 1 second here, my arrow, and you can move it around. See, like when it's not orange like that, it's inside the apple of illumination. When I bring it out like that, it leaves the apple zone of illumination, and it goes in front of the
Gegenschein.
Okay, I believe it's orange like that because of the glass sky, because red is the least amount of refraction when light goes through glass, and just the incident angle involved like that. I believe that's why the moon turns red like that. But that's why the lunar eclipse. Now, a lot of people, you know, initially when they try to refute concave Earth, they will say, well, how do you explain lunar eclipses? Well, now we can turn that around, concavers. How do you explain the
Gegenschein.
How can the moon be eclipsed right in the exact area where there is illumination? I'm sure you got an answer for that. You know, maybe, what is your answer? You got to pull something out of your ass, don't you? Concave Earth is reality. You understand that? You understand how much you've been lied to, ladies and gentlemen?
GPS towers, they're ground-based or low-end towers, and they're bouncing off the glass sky at 100 kilometers high. So an illustrator just made a quick little rendering to help you understand what's going on. We have the glass sky at 100 kilometers approximately, and I have a distance of about 1100 kilometers from the left to the right. Make sure you're getting all that. And basically now with the towers, the cell towers, the radio transmission towers that we have installed virtually everywhere on land anyway, what they do is they're beaming up a signal and they're hitting a hard specular coherent reflected surface, so that it's going to reflect the radio waves. That's the only way we can get radio wave, sky wave bounce to go across the other side of the Earth as well. And so the angle of incidence is going to be the same angle of reflectance. And these waves are going to be coming out, they're going to be emitting out like that, I suppose, in wave format, but there's going to be a central point where it's going to do the reflection like that. And if this is true, when they're going up with their GPS apps on their cell phones and they're going up and measuring the distances between the top of the towers versus the bottom of the towers, and they're finding out that they're getting a longer distance at the bottom of the tower, well then this is probably what's happening. The signal is getting bounced back, and there's going to be a shorter time for that signal to reach the phone at the top of the tower versus a longer time for the signal to reach the phone at the bottom of the tower. And so they're getting different latitude and longitude coordinates as well as elevation based upon other signals that are interfering with it. I got a triangulated signal coming from a different transmission tower as well, so they're getting the coordinates that way via triangulation, and the actual amount of time it gets to the actual receiver, the phone receiver. So that would be the same on the other side as well. And so with that, if that's really what's happening, the top of the tower is going to be shorter than the bottom. So that's how that would happen if that is the case. Those convex tards, they uploaded a documentary saying that they were getting the same exact distance, but they were lying. They were not showing you accurate data or anything. They were just giving you word of mouth. So the bozo Earth clowns fail. And so I asked a friend of mine, Ruben, if he can actually go out and perform another GPS phone app test on buildings. So if you guys out there, if you want to do it as well, be my guest. But if this is truly the case, if this is happening this way, it's because of the actual amount of time the signal takes to reflect back down
And if it's at a higher elevation, it's going to be a shorter time. So that's the GPS spoof. There's no satellites. I mean, there are satellites within the Earth, but they're not GPS satellites. They're, like I said before, you have the Solar Dynamics Observatory, you got these geostationary satellites, you got these geosynchronous satellites that are doing figure eights up there, but it's all inside the concavity of the Earth. Those satellites are anyway. So there you go. It's much more reliable and accurate to actually just use a ground-based system to get accurate results like that.
Okay, plotting the moon within the concave Earth. This is a top-down view. We're looking at the celestial sphere in the center, the sun, and the moon. And out of the three objects that are interplaying here, we have the celestial sphere, which is the fastest at 23 hours, 56 minutes, 4 seconds. Then, of course, we have the sun at 24 hours. That's the tropical year. And then the moon is the slowest of the three, and it goes 24 hours and 50 minutes every revolution, every day. So as you see it moving around here, we have a little marker indicating our place on the Earth. Looks like we're in Africa somewhere. And once it accumulates to 27.32 days, that marks the sidereal month of the moon. That's how many days it takes for the moon to align back up with the celestial sphere. And if we go on to 29.53 days, that is what is called a synodic month. That is where we mark new moon to new moon, where the sun and the moon align up. Looking front on, we see the declination range of the moon and the sun as they pass across the sky. From left to right, we see the termination line of the moon changing from day to day. We also see the backside of the moon. This is the lunar month of January 20th to February 18th. We see the equator there is actually shared with the celestial sphere. That means there's no tilt to the Earth. We can also see the sun's ecliptic at negative 23.5 to 23.5, which means the sun is oscillating in a cylindrical path from year to year. This cycle for the moon is called the draconic month at 27.21 days. And the lunar standstill of 18.6 years is the time in which the moon actually fluctuates in the sky, going from very high to a major lunar standstill at negative 28.5 to 28.5 to a lower minor lunar standstill of negative 18.5 to 18.5. This October, we are entering into a minor lunar standstill, so the moon will not ascend or descend that high in the sky. When the sun is low like that in the south, the bond it has with the top of the pyramid loosens, so it gets closer to the Earth. That's why we have a bigger angular diameter of the sun in the south. This is also how we can predict lunar and solar eclipses, because everything is synchronized within this time mechanism of the concave Earth. The simplest answer is always the best answer. Occam's razor.
Okay, what we're looking at here, you can see, hopefully, I'm going to run the light along the beam here. There is what looks to be a 2x12 that is absolutely smashed from the top. You can see up there's a lighter portion on the skip sheathing where the beam has come away, where the rafter has come away from the ceiling. This had to be an incredible impact. You can see the break line.
Brian, this is like what was on the floor.
This is the piece that came.
Yeah.
I have to believe something that big, which we have to assume it's lost some mass in the heat, but
yeah. So there's another
piece
in the same.
It had to be going at an incredible rate of speed.
Yeah.
Ice. But ice is our friend. We skate on it. We put it in our drinks. We use it to help relieve injured muscles. But no. This ice was not nice. It was huge. Just like this one. Weighing about 20 pounds. Imagine this crashing through your ceiling. So where in heaven's name did a piece of ice this size come from?
have absolutely no idea where it came from. It's made a huge dent in the garden, but there's tufts of grass over there. It could have hit the house just behind us. It could have hit one of the kids or the dog.
So I was sitting about 3 feet outside the kitchen door when I heard a huge, what sounded like an explosion. And I thought I was going to get up and look outside and see some horrific thing outside. I kind of turned to my left, which would have been towards the kitchen. And in that instant, the kitchen had been destroyed. I had beams hanging, ceiling had crashed in. Just unbelievable. And I was in shock, just speechless. I was too dumbfounded to be scared at that point.
Above in Brooklyn, chunks of ice falling from the sky on an 80-degree day. The big question, where did it come from?
Well, this car was going 0 miles an hour when it got into an accident. A chunk of ice fell from out of the blue and crashed through its windshield while it was parked at a central Pennsylvania car dealership.
In Charleston, South Carolina, a chunk of ice half the size of a car, fell out of the sky, ripped through the roof of an automobile dealership, and flattened the roof of a new car parked inside the building. A spokesman for the fire department said the ice put a 3-foot hole in the roof. Like the other falls, this one occurred in January of 2002. Theories as to the origin of the big blocks of ice has ranged from the effects of global warming to discharges of wastewater from aircraft flying high overhead. But an examination of the ice that fell last year in Italy and Spain revealed this was comprised of pure and nearly distilled water. The global warming theory is also ruled out by the stories that have been passed down to us from the past, like my old news clippings from the boat captains of the Great Lakes in the 1880s. There have been some spectacular ice falls in the past, way before the invention of aviation, mind you. In the late 1700s, a chunk of ice as big as an elephant, reportedly fell on Seringapatam, India. It was so large it took 3 days to melt. In 1802, a lump of ice fell in Hungary that had a volume of 18 cubic feet.
Where does the Megacryometeor come from? The only explanation is that it is coming from a mantle, a sheet of ice that's connected to a literal glass ceiling to the sky at 100 kilometers high. Earth is hollow, stationary, and concave. It contains the tiny sun, the moon, the planets, and the stars. We live inside it. At 100 kilometers high, there is a convex glass ceiling to the sky with a sheet of ice adhered to it. On clear, hot days, a piece of ice routinely falls down.
This is from Sporadic Meteor website. Sporadic meteors don't come from completely random directions, which their name implies. Most sporadic meteors come from 6 sporadic sources. Look at this. Look at this imagery. Look at this imagery, people. We have the celestial sphere in the middle of the Earth. We have the north apex side of the pyramid. We have the south apex side. I also mentioned to you before that the northern side was brighter than the southern side. Okay, now of course they're going to twist things. They're going to try to fit this in within a heliocentric model. They're going to say, well, the apex is in the direction of Earth's motion, so apex meteors collide head-on with Earth. The helion and anti-helion, these are the helion and anti-helion sources. Now this is also interesting too, because I mentioned before, on one side we have the sun, and then we have the anti-solar point, the Gegenschein. It's right there in plain sight, people. So, and then they also talk about a toroidal origin too. Let me see if I can get that one to you really quick here. There it is. Toroidal origin of meteors. Look at this, guys.
Something we can pick up with radar. Seymour radar picks it up. It's right there, guys. Undeniable proof. Get with the program, guys.
Now look what we have here. You see the north apex of the octahedron pretty much stays
visible throughout the whole year. However, the south one only becomes visible during part of the year, i.e. when the sun goes south in the wintertime. And so we're getting a preference of warmth or activity more in the northern side, on the northern side. So this is really why the northern hemisphere is warmer than the southern hemisphere, because it not only has the sun, which is orbiting cylindrically around the celestial sphere yearly, but it also has the north side of the octahedron. The Bible calls it the sides of the north in the book of Isaiah 14 and Psalm 48, I believe. So the sides of the north, the top of the north apex side of the octahedron stays lit or stays warm throughout the entire year. And that's also why I believe we're seeing these hotspots here at the top, because I believe that the north side is emanating this magnetism, this heat, this light. The Father of Lights is behind the celestial sphere at the top, the sides of the north.
The Milky Way band, it's a band, it's not a spiral galaxy. It's actually a literal band that separates the celestial sphere into two different hemispheres, two different magnetically influenced hemispheres that actually steer the sun. So the Milky Way band has a function. So when the sun crosses that galactic plane every 6 months, it's also exhibited by the Ulysses satellite. They show that every 6 months the sun is oscillating back and forth. So when it crosses that plane, it steers the sun in the other direction. Like when it's up north like that, it's going to steer the sun south, and then conversely the same when it goes down south. When the sun goes down south, when it crosses that plane, it's going to steer the sun back up north. So it's all being influenced by that dividing line, that Milky Way dividing line. It has a purpose, it has a function. Everything works within the concave.
The silica glass also contains carbonaceous inclusions consisting of 5 to 50 nanometer thick polygonalized graphite ribbons that form closed structures up to 200 nanometers in diameter. So the graphite ribbons. Now, negative refraction, if you go to Wikipedia, you look up negative refraction, it will say negative refraction is a name for an electromagnetic phenomenon where light rays are refracted at an interface in the reverse sense to that normally expected. Such an effect can be obtained using a metamaterial, which has been designed to achieve a negative value for both electric permittivity and magnetic permeability. Now, metamaterial is a man-made material. Metamaterials are artificial materials engineered to have properties that have not yet been found in nature. However, graphite, this study right here says graphite, which is not a man-made material, it's actually a natural material, has been found to produce negative refraction under certain ultraviolet conditions. I'll find that for you right here. Negative refraction at deep ultraviolet frequency is monocrystalline graphite. Monocrystalline graphite. Using ellipsometry measurement of the equifrequency contour in the deep ultraviolet frequency region, typically 254 nanometers, obvious negative refraction was demonstrated in monocrystalline graphite for incident angles ranging from 20 to 70 degrees. This negative refraction is attributed to extremely strong anisotropy in the crystal structure of graphite, which gives the crystal indefinite permeability. So, you'll have this little graphic here where I show that I explain what I just read to you, okay? There are little ribbons, microscopic graphite ribbons within the glass that are creating a negative refraction in the sky. So it's actually inverting the sky to give you the illusion that the sky is a dome. So I can just go into Illustrator here. I'll show you really quick. I just made this graphic really quick.
Here is the concave Earth, and you're standing on the inside surface. Okay, this thick black line is the surface of the Earth. And if I zoom in real close here, you know, I got an observer here, and this yellow line is the glass sky. Now, let me get the right layer here for you. Okay. Now normally, okay, these purple arrows, normally, that's a normal refraction. It would shrink objects from Earth's perspective. So if you're down here, if you're looking up into the sky, it's shrinking the heavenly objects. And it's giving the normal indications of normal refraction. However, because of the graphite ribbons within the glass sky, it is actually inverting the sky, so it's diverging outward toward you. And that's also why I believe we get the sun and moon illusion at the horizon. With this negative refraction, it simply just turns the convex dome inside out, and you get actually a greater refraction at the extremities here. Okay? The greater the incident angle, the greater the squishing and the greater refraction like that. And so this little blue area would be the apparent dome illusion. The dome illusion that you think is the sky. Negative refraction in glass creates the sky dome illusion. Okay, so light is bending within the Earth. If you're new to this phi ratio trajectory of vision is showing how light actually bends. It gives the illusion that you're living on a ball. And with this negative refraction of the glass sky, it inverts the heavens. Okay?
So within the concave Earth, there's the sun. The sun is propagating its light. It's on a curve. Everything is moving on a curve within the Earth. The sun ray passes through the glass. It's going to bend back up around, and it's going to hit the comet. So when we see a comet's tail, it splits like that. That is an example of birefringence.
see the north apex of the octahedron pretty much stays visible throughout the whole year. However, the south one only becomes visible during part of the year, i.e. when the sun goes south in the wintertime. And so we're getting a preference of warmth or activity more in the northern side, on the northern side. So this is really why the northern hemisphere is warmer than the southern hemisphere, because it not only has the sun, which is orbiting cylindrically around the celestial sphere yearly, but it also has the north side of the octahedron. The Bible calls it the sides of the north in the book of Isaiah 14 and Psalm 48, I believe. So the sides of the north, the top of the north apex side of the octahedron stays lit or stays warm throughout the entire year, and that's also why I believe we're seeing these hot spots here at the top, because I believe that the north side is emanating this magnetism, this heat, this light. The Father of Lights is behind the celestial sphere at the top of the sides of the north.
Look at this. Look at this imagery. Look at this imagery, people. We have the celestial sphere in the middle of the Earth. We have the north apex side of the pyramid. We have the south apex side.
As the sunlight disperses through the glass, it gets projected onto reflective water droplets. The water droplets are not the source of the rainbow, but merely the reflective canvas of the already glass-dispersed light.
So what I did was I turned that prism upside down, because it's easier for, I think, people to understand. If you're living on the inside, the concavity of the Earth, you have the red on the bottom here. The red is bending less than the violet. 750 nanometers versus 380 nanometers. So the shorter wavelength is going to bend up more away from the Earth as opposed to the longer wavelength. And especially when you get into the longer wavelengths like the microwaves and the radio waves. That's why you can see more with infrared waves, which are, they're longer than the reds here. You can see more with an infrared camera than you can with a normal light camera, because it's a longer wavelength.
But there is most likely at least 3 concentric spheres of glass in the Earth, apart from the main celestial sphere. This is detected easily by viewing the 22nd degree halo and the 46 degree halo.
So what I did was I turned that prism upside down, because it's easier for, I think, people to understand. If you're living on the inside, the concavity of the Earth, you have the red on the bottom here. The red is bending less than the violet.
The underside of clouds. How do we see the underside of clouds? Well, if you understand that light can only bend, and
and it bends within the concave Earth, you will understand simply that, like in this diagram here, the sun is up here and it's emanating its light. It's curving more so here toward the sun, and then it curves around like that. It creates a horizon line there, and then bends back up. So if we zoom real close in there, we see the sun hitting the horizon and then bending back up to illuminate the underside of the cloud. That's how the underside of the cloud is illuminated. And this only happens during sunrise and sunset. Obviously, when the sun is closer or higher up in the sky, it's not going to have the extreme angle. It's going to be like more over here, like in my flash animation here. So if the sun is like over here, it's not going to be able to illuminate the underside of the cloud. It only happens during the sunrise and the sunset. Okay, this is the only way it's possible. This is the only correct model.
See, the horizontal blue lines, that indicates the moon's cylindrical orbit, and the horizontal dotted yellow lines indicates the sun's cylindrical orbit. And as I mentioned previously, I indicated these little shoot zones with these orange lines. So whatever latitude you are at, you're looking at the sun through this little scope zone. So if you're over here, let's say this is at like negative, I don't know, 8 degrees. Or actually this is negative 23.5, I'm sorry. And the sun is directly in front of, or the moon is directly in front of the sun, we're going to get a shading right there. However, if the moon is a little bit lower in declination, in this little illumination zone, it's going to carry the moon shadow at a more extreme latitude. So I brought that into 3D here, and so I morphed the moon shadow so you can better visualize what's going on here. As you see, as I scroll across the timeline, the shading is morphing, and the declination of the moon within that illumination zone is really critical as to where it's going to project the shadow on the Earth. If it's a little bit lower in that zone, it's going to project it like that. Let's say the sun, like I'm actually rotating the sun as well here, so this is like, maybe this is like, I don't know, negative 10 degrees or so. And if I scroll a little bit more, it's going to get more extreme like that. And that's how we're going to be able to pick up a shade zone in the very southern polar regions, or the northern. I just did the southern for this video. And of course, as I mentioned before, if that moon leaves that illumination zone, let's say the moon is right over there, it's not in the illumination conical zone anymore, so that moon shadow is going to wrap around. It's not going to hit the Earth, and it's going to curve around and converge to the other side, very similar how the sunlight converges to the other side and creates the Gegenschein at the anti-solar point. So there you go. I think this helps understand, helps visualize what is going on with the solar eclipses inside the concave cellular LSC Earth. All right, there you go. Pretty cool. Thanks for watching.
On board, the team reviews the stunning and unique images. This sprite was shaped like a mangrove tree. It's been captured in more detail than any sprite until now.
It's like lightning that happens above the clouds. And so these people, they went up in airplanes and they documented these sprites. They took high shutter speed camera because they don't happen that, I mean, this happens like almost instantaneously. But you'll notice here, this top of this plume of this upper atmospheric lightning, it hits a barrier, it hits a wall. It's hitting the glass sky. And notice they even say it's at 60 miles high. Well, the glass sky is at 100 kilometers, which is roughly 62 miles. So, play a part of this video. It's pretty wild.
Sprites of many different forms appear, one after another. Seen up close, they have a variety of shapes. Eventually, a sprite appears that demands special attention.
This is spectacular.
The umbrella-like top of this sprite reaches an altitude of around 60 miles.
Look at that. It's hitting a wall. It's hitting the glass sky.
It's the altitude of the air.
They call those Elves. E-L-V-E-S.
That's the altitude of the airglow layer that appeared in Furukawa's footage from the International Space Station. The image confirms that sprites interact with the ionosphere.
Well, yeah, the ionosphere is actually just glass. It's an insulator. Okay, the Earth is one big capacitor. Concave Earth capacitor. There's a gap between the electromagnetic forces from above the glass versus the ground, and the glass is the insulator. So the lightning bridges that gap, just like in a plasma ball. That's what's going on. So the top of the slide, it's like you're touching your finger on the glass of a plasma ball. That's what's happening with the top of this sprite. It's the same concept. It's hitting the barrier. It's hitting the glass barrier. That's why the bottom end of auroras are at that same level. 100 kilometers. There's glass in the sky, folks.
Is the sun actually, do you believe, combusting in on itself?
It's not burning anything. There's no fusion in the sun. That's well understood.
Proven.
Yeah, well, there's just not the way to prove that there is any. It's only in the flares that you get fusion. That's why all the X-rays. The flares, the arcs, and the X-rays, and the microwaves, and whatever result of fusion in the arcs. There's no fusion in the sun. They don't know how the sun works.
Why do you, what's special, how does the sun make light?
It's a transformer. Transforms from some other dimension. It's not burning anything. It doesn't have to. It's a converter.
Of what?
I don't know. Nobody knows. But that's what it does. That's the only thing it can do, because that's how everything works.
I say it's the pyramid in the middle of the Earth. That is the source. That's the anode to the cathode. Okay, you have an electric current going. You have a circuitry you're connecting. You're going from the top of the pyramid to the back of the sun. And the sun is revolving around the inside of the Earth. So with these probes, this is how I believe what they did is they, in the south, during the summertime when the sun is farthest away, they get a better angle of the south side of the sun. Same thing in the north. If you're up here during the winter solstice, the sun is down here, you get a better angle of the north pole of the sun during the winter time. And so that's how I think that is what's going on. Also, I'm going to get into the different velocity, rotation, speed, the different velocities of the sidereal rotation of the celestial sphere and the solar rotation of the sun. Now they will tell you there's an apparent difference, the heliocentrics, the heliocentrists, they will tell you there's an apparent different rotation because of how the Earth spins relative to the background of the stars as it's orbiting the sun in different positions away from the sun.
But that's not true. There's actually, just how there was how they say there's an apparent retrograde motion to the planets when there actually is a literal retrograde within the concave Earth due to magnetism, there's also a literal difference in velocity between the celestial sphere and the sun. The celestial sphere is going slightly faster than the sun, 4 minutes faster. The sun is 24 hours, the celestial sphere is 23 hours and 56 minutes.
Transferring from another dimension.
Yeah, you could say it's taking energy from another dimension, counter space. There's no energy, actually. You can't, most of it you can't even measure in outer space or see.
You can't see.
No, you can't see the sun in free space.
So the sun is not visible in outer space.
Not in free space. It's only invisible when gross matter becomes involved, like the Earth's atmosphere and envelope and the surface of the moon or whatever. That makes the light. Otherwise, there is no light. You can see the moon, you can see the Earth, but you can't see the sun or you can't see the stars.
But you can see the planets and the satellite.
Right. You can see material objects, but you cannot see the sources of light. There is no light until there's a material object.
To reflect off.
So that means there's no time delay. So the whole time delay thing is meaningless. It doesn't take light years. There are no light years.
You look here, okay, I have this labeled here. When the sun is at its highest, its crest in the summer solstice, it's going to start turning. Remember how they told you the tilt angle relative to the ecliptic? So the sun is going to start turning counterclockwise, going south now, as it passes through the Milky Way. The Milky Way steers it somehow. Must be like, what I think is this whole celestial sphere is pretty much dark and very thick clouds. The Bible says thick clouds of the sky, or dark water and thick clouds, and so I think that Milky Way band is a little bit thinner. That's why we see light coming through, and so there must be some kind of change with the thickness or the thinness of that light, and is changing the rotation of the sun slightly. It's just the bank angle, I guess you would call it.
It's a law, you know? The world must believe. That's all there is. The sun is an atomic bomb burning in the sky. If you don't believe that, you're going to go to jail.
Okay, now, your theory on the sun, I want to get.
It's hollow.
So every planetary object is hollow, right?
All hollow. Well, the sun's definitely hollow, because I studied the sun for 4 years straight.
This is a question.
And it's obviously hollow. Okay. And the solar, the sunspots are holes that allow you to see inside.
Really?
Yeah. It's dark inside. The sun is well understood in radio physics and studying the ionosphere and sunspots and all that stuff that the sun does not operate by fusion. They do not know how the sun operates. The fusion only comes out of the arcs because of the current density. That's where the hydrogen fusion occurs, is in the actual arcs between the flares. The sun itself is not a fusion device.
So the fusion is in the effect of the
It's a
flare.
converter. Yeah, the sun is a converter from another dimensionality into this dimensionality, and obviously if you can't see it in outer space, the conversion's not complete until it hits the Earth's atmosphere or other physical object, and then it finally converts to electromagnetic light.
When it hits the ozone layer, it does
Well, the
something.
Earth's envelope.
The Earth's envelope.
Yeah, Earth's envelope is undefined.
Undefined.
Yeah, but you have to get in the Wilhelm Reich about that. Like we were talking about how you can't see the stars anymore.
Yeah, yeah. So the sun, would you say it makes its quote-unquote energy through some electrical etheric process?
Yeah, because of its voltage, its position.
Would you call it some kind of etheric lamp? A lantern?
Yeah, it's like a giant Tesla lamp.
You know, in the converter, the sun is a converter.
Yeah.
There's convection going on. Well, no, Donald Scott talks about how there's a temperature minimum in the chromosphere. So you got the sun, you got the surface of the sun would be the photosphere, and then the chromosphere, and then the corona. And it doesn't work that way. He's talking about how a nuclear reactor doesn't work that way. There can't be a temperature decrease and then all of a sudden an increase. But and then of course CMEs I think happen a lot slower within the concave Earth. I mean, they're talking they're saying they get really fast, like up to 1 million miles an hour. Well, that's because you're already thinking that the sun is 93 million miles away. It's not. So everything is within the Earth. Everything's happening, as far as CMEs, it's happening slower. All right. I think that does
does it for this video.
The sun is the negative power supply to the octahedron, and the power supply proves it's vibrating. It's like the sun spins around the celestial sphere and it sucks up electrons off the negative Earth. It's the negative terminal. And light occurs from the electrons being funneled up and converging into the sun. That's where the sun's light comes from. Like a light bulb kind of. Light emits when the electrons go through the filament. So you can't always assume things go one way or the other. Things could be going two ways.
Look at all this evidence that there's a glass sky. 22 pieces of evidence. Number 1, rainbows, halos, glories, circumzenith arcs, sundogs, and other atmospheric optics, which are created by sunlight passing through glass and being projected onto water vapor. Oh, Romans 8:36. Thanks, Fist. Number 2, Libyan desert glass. The mystery of where it came from is solved if you realize that there's a glass ceiling in the sky. Number 3, tektite origin. You guys know what tektites are? That's another mystery. Scientists, they don't know where the tektites are coming from. They don't know if it's coming from the ground because there's no impact craters where they find them, or if it's coming from space. They don't know. Number 4, Megacryometeor origin. Large chunks of ice that fall down from the sky randomly, infrequently, but more frequently lately. Now we know where they're coming from. There's actually a whole ice sheet connected to the glass sky. For you were as sheep gone astray, but now returned unto the shepherd and bishop of your souls. Amen. Number 5, birefringence. Birefringence is created through different glasses, different types of material like calcite, where it actually projects a double image, a double refracting image. So sometimes you'll see double suns in the sky. Sometimes you'll see a quadruple rainbow where it's like an offset, like there's another rainbow that's displaced a little bit from the original rainbow. Or you'll see a comet's tail splitting like that. That's all because you're viewing these phenomena through a birefringent glass sky that at certain rotation angles of the sun, because it's polarized in a certain direction, sometimes casts a double image. It's a very weak birefringence. They found it in the Libyan desert glass. They found weak birefringence. But at certain times, at certain angles, it will appear. 6, ozone. Ozone. Did you realize that ozone is actually generated with the help of the glass sky? And that fresh scent that you smell after thunderstorms? That's the same fresh scent that's replicated in air ionizers with glass plates. The glass actually helps manufacture that fresh scent. Fusion crust. Meteorites are covered with fusion crust. Fusion crust is burnt glass. That means that meteors are melting through the glass and getting covered by burnt glass, by a fusion crust. Colorizing of clouds. Sometimes you'll see clouds, they have like a rainbow pattern to them, or reddening of the clouds at the horizon. That's all due to the glass, which casts different colors through different regions of the sky. That's what glass does, folks. Glass disperses the white light. Yeah, the fresh scent after the long cut, that's a good smell. Fist. Greenhouse effect, number 9. Obviously, a greenhouse has a glass ceiling. Same thing with our sky, has a glass ceiling. It traps air, hot air, infrared heat. Number 10, the Kármán line. That is the line at 100 kilometers is said to be the division line between the atmosphere and space. Interesting. That's the same height as the glass sky. Number 11, ultraviolet radiation block, UV block. Did you know our atmosphere blocks out a lot of ultraviolet light? And did you also know that glass blocks out ultraviolet light? Did you know that? Number 12, lightning. If you ever watched an Eric Dollard seminar, you'll realize that lightning is created by dielectric forces moving laterally near glass. Lightning doesn't form from the top down or the bottom up. It actually forms from the sides. The dielectric forces in direct perpendicular positioning of the electromagnetic forces. Number 13, Elves and upper atmospheric lightning. Sprites are called upper atmospheric lightning, and so are Elves. Elves are the top of the Sprites, and they taper off. They stop. They create this plume at 100 kilometers. That's the height of the glass sky. Number 14, shortwave radio, ham radio. It scatters at 100 kilometers. They compare the ionosphere to a sheet of glass. Well, there's no need really to compare it to a sheet of glass because it actually is a sheet of glass. That accentuates the radio waves and passes them along to the other side of the inside of the Earth. Oh, it's a tab happy guest. Number 15, Operation Fishbowl. You guys remember Operation Fishbowl in 1962? Maybe you weren't alive back then. Starfish Prime. Well, I don't believe they have nuclear weapons, but they said they launched a high-altitude nuclear weapon that exploded at 400 kilometers, and there was an auroral display visible from Hawaii and many other places. See, auroras are created because there's glass. So they burst a hole in the glass sky back then. Operation Fishbowl, does that sound a little bit fishy to you? Well, it should. Number 16. Superior mirages, fata morganas. You know that sometimes at the horizon you'll see this horizontal crease at the edge, and it looks like the sun is going down and going up. It has like a double image to it. Well, that's because the glass actually, due to refraction, creates a horizontal crease, and sometimes it's visible at higher latitudes. Number 17. Meteor showers, iridium flares. That's all it is, guys. It's the cyclical skidding of inner space debris, particles skidding, creating streaks. There's also a term called triboluminescence. When you rub quartz together, or you rub a rock against quartz, it will light up. So when you see shooting stars, meteor showers, it's because they're skidding across the glass sky. That's all it is, guys. Number 18. Redshift. You've probably heard that you've been told that the universe is expanding because they see the redshift of the stars. Well, nothing can be further from the truth. What they don't understand is that there's actually 2 layers of glass, one at the 100-kilometer level and the other at the celestial sphere level. So you're viewing the stars through 2 layers of glass, and it's creating chromatic aberration. It's creating the colors. It's creating the shifting. That's all it is. It does not indicate movement away from you. They say it's like the Doppler effect. There's nothing further from the truth. All stellar spectroscopy is debunked due to scientists ignoring chromatic aberration of stars caused by glass. Number 19, aberration of light, stellar aberration. Sometimes astronomers will see slight movement in this, like a displacement in the sky, in the stars, and that's only because the glass sky, it creates a slight apparent displacement of stars due to the refraction. Number 20, space vehicle heat shields, re-entry or entry. They have flush bottoms. They have high temperature resistant material like carbon-carbon matrix used to melt through the glass. And it shall come to pass when I bring a cloud over the earth, that the bow shall be seen in the cloud. Yes, Genesis chapter 9, verse 13. The glass sky was formed after the flood, the global flood, ladies and gentlemen. Prior to the flood, there wasn't a glass sky. But we needed, within the concave Earth, within this pressurized system, we needed to push. God needed to push the waters down. So he compressed the atmosphere with the glass sky. That's why the rainbow is a promise. It's a scientific promise that the Earth, the continents, can never be flooded again, because there's more pressure now. There's more compression. 21, Crookes dark space. There's a man named Crook in the 1800s who found negative charged ions create dark space around glass tubes. It's the same thing with our glass sky. If you read Job chapter 38, verse 19. And as for darkness, where is the place thereof? See, it's hidden. Deep beneath the cover is another perfect wonder, and it's so white as snow. 22, auroras. It's at 100 kilometers. The bottom edge, the bottom end of auroras is at 100 kilometers. The electrons from the sun hit the charged glass sky, causing fluorescent glow and striations. Exit the matrix of deception, people. There is glass in the sky, in the concave Earth. During the time of the flood, these sonoluminescent stars, they clustered together and they became very hot, and they began to melt through the glass celestial firmament and creating these little pockets, these little indentations and openings. The windows of heaven were opened, right? The windows of heaven were opened, and so the water came down. The water also came up from the fountains of the deep of the earth. So we had water coming down and water coming up. And so after the water came down and after the sand came down too, the sand is what created this secondary firmament at 100 kilometers, which actually pushed the water down. That's why we have the rainbow, because the sun is within this region here. So the sun is only a half sphere. Everything is operating on curved light. And so that's why we see rainbows, because the sun is being dispersed through this glass medium and being projected onto the raindrops. The raindrops are not the source of the rainbow. But anyway, going back to the celestial sphere, glass sky, it healed back together. So it closed up. The windows of heaven were closed after the great flood. So now you have these indentations, these peaks and valleys. This glass celestial firmament, because of the way it had been ruptured, it had been opened up, and then it healed back together, it's not perfectly smooth like that. It's more like this glass here. Okay, I've been asked about how the horizon works within the concave Earth. I told you before, light bends. It's been proven to bend. There's been experimentation on light bending.
And what I think is happening is we have this phi ratio curve extending from the observer like that. Okay, this is an assumption, but I think it's very possible since phi, the golden ratios throughout nature. So I just do this comparison and contrast between a concave Earth and a convex Earth. If we're standing on a convex Earth and we see light being straight, we see the sun over here. However, that's not the case. We're in the Earth, so basically the sun flips its orientation on us. And so what we think is the top of the sun when it rises like that is actually the bottom of the sun. The moon here is a little bit closer to us, and so it would start a little bit later. However, because the moon is slower in the sky, 25 hours to go around as opposed to the sun going 24 hours, it would take about the same amount of time from moonrise to moonset as opposed to from sunrise to sunset. Now, there's also an atmospheric refraction bulge that's created. That's why we see ships sinking in the distance. It's actually just an illusion. However, because we have this bulge, that creates an edge for us. So that creates a threshold. So that's why we see a literal horizon. And so this threshold extends all the way up like that. And so that's the clipping point. So this blue line would be the clipping point when the sun and the moon start, and the horizon starts like that, extends up like that. Going over here, we can actually assume the distance of the sun away from us, if this curve is the correct curve, based on knowing that we know the diameter of the Earth, which would be 7,918 miles. So if we just calculate that distance, the radius, 3959, this intersecting point of the sun would be 2106, 2,106 miles, which was I actually initially thought. You know, I said, the sun's probably about 2,000 miles away. So if that's the case, that's what it would be. And the diameter of the celestial sphere would be 1853 times 2, which is 3706. Also, the sun, I told you before about the darkness funnel, which creates over here on the opposite side. I would have to assume that the sunlight is a little bit sagging a little bit, because I don't think the funnel's way over here. I actually think it's a little bit lower, and so that's where that funnel would go. But that's what's really going on, guys. Light is bending up like that. It's been proven to bend. It does bend. Also, the visibility of stars beyond the pole axis, like if you're standing on the equator and you see those time-lapsed star trail photography footage, you will see beyond the pole star. And so if this light is bending up like that, this clipping point, you're going to see beyond the pole star, because this blue line would be the pole star axis. And so you're seeing beyond that. It all makes sense within the concave Earth. It's a masterful deception and illusion, but that's what's really going on. Also, like sometimes you will see the sun, they call this superior mirage. You'll see that horizontal crease. There's like a division line where the sun's going down, and then it gets clipped at this line, and then it rises up again. They say that's due to the temperature of the air difference, but I have a feeling it's caused by the glass sky. This refraction that's going on is creating this horizontal crease. I made a previous video about that. So there you go. That's how the horizon works. This is reality.
Okay, guys, I think I pretty much figured out why they use HARP as an atmospheric heater in other places like IceCat in Europe. There's an effect that they discovered about 80 years ago in radio. They called it the Luxembourg effect. And I'll just describe it briefly for you. The phenomenon was discovered in 1933 by B.D.H. Tellegen in Eindhoven, Netherlands, who was listening to a station in Barrow-Munster, Switzerland on 652 kilohertz. In the background of the Swiss signal, he could hear the audio of Radio Luxembourg. Okay, so like if I just go on this map here, he was in the Netherlands, and he was listening down here to a Switzerland radio station, and he could pick up Luxembourg radio. Now, these two radio stations are at different frequencies, so he was really just tuning into the Swiss frequency, but he was also picking up Luxembourg. Okay, so it was a phenomenon they couldn't understand because Luxembourg radio was on a different frequency. Tellegen noted that the 3 points were in a straight line. When the signal from the Swiss station made its way to the Netherlands, it passed directly over Luxembourg. He correctly theorized that the carrier of the Swiss station signal was being modulated in the ionosphere
as it passed through the strong signal of Radio Luxembourg in the ionosphere. The ionosphere had only recently been discovered and was not totally understood. It was previously supported that the ionosphere was a linear medium through which radio waves passively reflected. But the existence of the Luxembourg effect showed that the ionosphere could be artificially heated to produce non-linear effects. Okay. What he picked up was cracks. Okay. If you understand my cosmology, we're in the concave Earth, and there's a glass sky above us at 100 kilometers, and the bottom edge of that glass, or the bottom portion, the underside of the glass, there's a mantle of ice. Okay. So there are cracks, there are fissures in the glass or the ice or both. So when we see auroral activity and we see these hard lines, the auroras, the plasma of the auroras are running along the cracks of the glass or the ice. Okay, some of these images I think are CG, like from NASA and stuff, but most of them are not. So these fissure lines, these cracks, they're showing, it's evidence that this is a hard surface for one, and that there are cracks in it for two. Now, the whole reason I think HAARP and other atmospheric heaters, like IceCat and other places, are used because they are concerned about megacryometeors. They are concerned about this ice mantle breaking off and falling. I believe Tunguska was a huge megacryometeor event. If you watch my previous videos, you understand that megacryometeors are the source. The glass sky is the source for the megacryometeors. There's no other place where they can be coming from. Can't be just formulating in the stratosphere or the troposphere. They're coming from the top of the glass sky at 100 kilometers high, which has fissures in it, which has cracks in it. So, you know, ionospheric heaters, the whole reason I believe they are heating up the ionosphere at certain areas in the ionosphere is to fuse these cracks. Let's say they are made out of ice, okay, on the underside. If they apply heat to that region, that will fuse those cracks together and actually prevent the ice blocks from falling. In addition to how I mentioned before, how they spray the skies to prevent the heat from rising. So you kind of have like a, you know, you're heating the sky and you're also preventing the heat from rising as well. You're heating the sky in certain areas. You're heating the ionosphere in certain areas to fuse the cracks to prevent the ice from falling. And then you're also spraying the skies with the chemicals, the chemtrails, the strontium, the barium, the aluminum, to prevent the heat from rising, the anthropogenic heat from rising. So you have had like a dual effect here. They perform experiments with it. They say, we have built a setup allowing for an instructive experimental demonstration of the acoustic Luxembourg-Gorky effect, scroll down there, in the form of the cross-modulation of two longitudinal modes in a glass rod containing 3 corrugated thermally produced cracks. So they're replicating this whole process right here in this diagram here. They got these little cracks here in this glass rod, and they're finding out that it's getting the same effect as the Luxembourg-Gorky effect. So the glass sky with the ice on the underside has cracks in it. That's why we're seeing those striations in the auroras, because they're just running along those cracks. And they're concerned, I believe, that these cracks, at the edges of these cracks, the ice can crack off and fall down to the ground. And so they're trying to fuse the cracks. You know, they just kind of apply heat to fuse the cracks to make sure the ice doesn't fall. They're not going to tell you that. It's kind of like the Jack Nicholson, you can't handle the truth scenario, but that is why. So the Luxembourg-Gorky effect is solid proof that there is a glass sky above us. It cannot happen in just if there's just like a field of plasma above. No, there's a hard, tangible surface, ceiling to the sky. It's transparent. It's glass and ice. Okay, this is something they will keep from you, but this is something that I revealed to you. You're in the concave spherical Earth. The ionospheric heaters are meant to fuse the cracks to prevent the ice from falling. You understand? So this is
something you're not going to hear from any chemtrail activist or any other person who has no understanding that we're living in the concave Earth. There's a glass sky. This proves it, guys. The Luxembourg-Gorky effect. Talk to you later.
What they totally missed it. I think this image that they're producing with their radar imagery is indicative of sporadic meteoroids. Okay, it's quite plain to see. This is just it's radar imagery of the octahedron in the middle of the concave Earth, along with the celestial sphere, and then it has these hot points. There's one at the top here, and then there's one at the sides. They call this one the helion and the antihelion, and this one the toroidal. But what they did is actually they went through the whole year. So you have the 5th day of the year, the 15th day of the year, all the way up to the 355th day of the year, meaning that 365, well, I'm not sure why they don't have 365, but I guess they went by fives. So what I did was I brought it in Photoshop, and I did a little animated GIF of it. I'll play that for you right now. play. There we go. Now look what we have here. You see the north apex of the octahedron pretty much stays visible throughout the whole year. However, the south one only becomes visible during part of the year, i.e. when the sun goes south in the wintertime. And so we're getting a preference of warmth or activity more in the northern side, on the northern side. So this is really why the northern hemisphere is warmer than the southern hemisphere, because it not only has the sun, which is orbiting cylindrically around the celestial sphere yearly, but it also has the north side of the octahedron. The Bible calls it the sides of the north in the book of Isaiah 14 and Psalm 48, I believe. So the sides of the north, the top of the north apex side of the octahedron stays lit or stays warm throughout the entire year. And that's also why I believe we're seeing these hotspots here at the top, because I believe that the north side is emanating this magnetism, this heat, this light. The Father of Lights is behind the celestial sphere at the top, the sides of the north.
Morrill states that the rectilineator consisted of a number of sections in the form of double T-squares, each 12 feet in length with braced and tensioned cross arms 4 feet in length. The material was 1-inch mahogany, seasoned for 12 years in the shops of the Pullman Palace Car Company from Chicago. The horizontal bar was 8 inches in width and the cross arms 5 inches. He used steel tension rods marking an X across the entire section and extending through the extremities of the cross arms. They were adjusted to maintain the constancy of right angles. Finely trimmed brass facings at the extremities of the cross arms constituted the adjusting surfaces. Through flanges in the facing, ingenious screws were placed for securing the adjustments when made. Each section was supported by 2 strongly built, platformed standards, with adjustable castings to receive the horizontal sections between the body of the castings and adjustable cleats with clamps and set screws. The beams rested in the casting edgewise. The principle involved in its operation was as simple as the placing of 2 rectangular plates in contact, or laying 2 mechanics squares together. From the first to the last of the 1045 adjusted sections, the same procedure was methodically performed. 2 standards were placed in front of the previous adjusted section and placing the castings at the approximate height. The new section was placed in position in the castings. Initially, they turned the set screws to raise or lower the horizontal axis to approximately the height of one of the middle brass lines of the previous beam. The brass facings were then brought to 1/4 of an inch of contact. Operators of the set screws were directed to raise or lower the section to bring the hairlines exactly coincidental. Fine lines were read with the microscope, and the section was carefully moved horizontally by 2 set screw operators turning each screw in unison as the facings get to 1/50th of an inch apart. Then a Bristol card is placed between each facing with equal friction to ensure exact spacing. When the same card passes through each facing top and bottom with equal friction, it proves that the adjustment is precise. Then finally, the 2 sections are bolted together at the 2 brass facings, top and bottom, with equal torque, and the procedure is repeated. They had watchmen guarding the apparatus continually throughout each night to ensure no one tampered with it. As expected, because measuring the curvature of the Earth will happen in a logarithmic fashion, increasing exponentially toward the end of the survey, there wasn't any detectable deviation for the first few sections. But after that, it was a done deal. As soon as the airline showed consistent deviation in the descent, the sign of curvature of the Earth already could be determined. And it was, of course, concave. What still needed to be determined was if the amount of descent was consistent with the circumference of the Earth, and it was. After 1 mile, it measured 8.02 inches, only 2/100ths of an inch away from an even 8 inches. That, my friends, is the work of a genius. After 2 miles, it was still fairly close, 30.62 inches to the generally agreed 32 inches. And at the end of the survey at 2 3/8 of a mile, the descent was 48.25 inches. At every 12th adjustment, the spirit level was read. If the bubble began to deviate to the south, the Earth would show to be convex, and if to the north, then concave. The bubble consistently rose to the north of the vial. The plumb line was also used and hung over the 4-foot vertical crossbeams. In converse manner to the spirit level, if the bob shifted to the north, it would show convexity, but if to the south, then concavity. The plumb bob consistently shifted to the south again, further corroborating concavity. The 12-foot mercurial level would measure the angle of divergence within the length of the beam. This deviation would become more apparent at the end of the survey. Morrow also used the telescope to view the horizon from 15 feet behind the last section in the line. He noticed a continual sinking of the airline going below the horizon, which further proved the Earth was curving upward. There were 3 main measurements when all 4 of these appurtenances were used. One at 1 mile, one at 2 miles, and one at 2 3/8 of a mile. The results all agree in testimony of concavity. The remaining line-of-sight phase of the survey proved to show a fairly expected amount of descent as the airline passed through the excavated sandbar after Gordon passed to finally hit the water's surface. Morrow placed a steel horizontal strip at the height of the last recorded measurement protruding from stake 20 at the 2 3/8 mile mark, then moved back his telescope to stake 19, 1/8 of a mile away, where the heights of both markers were aligned to point through the excavated sandbar and wait for the bottom of the hull of the sailboat to line up. Through signaling, it was determined, and the crew on the boat calculated a 4 1/8 mile distance from the stationary tide register. The survey was complete and deemed a complete success. And the data speaks for itself. It wasn't tampered with. Even Simonek admits it appears genuine. And you begin to really see the lopsided victory for concavity when you take the numbers from the column distance of airline below secondary datum, or the amount in inches of deviation every 1/8 of a mile, and plot them on a graph. You see how accurately it matches the calculated amount of curvature to the Earth? The selenelion is a term in which they use to describe the phenomenon when the sun and the moon are above the horizon during a lunar eclipse. How can that be happening? They will tell you it's because of atmospheric refraction. However, within a standard conventional heliocentric model, there is not enough atmospheric refraction to compensate for the amount of lift of the sun and the moon. This is a previous illustration I made showing the propagation of light within the concave Earth. I showed you how the lunar phases happen. And so what I did was I simply show you how these glass skies, these concentric layers of glass sky, is actually refracting the light and causing the lift that is happening. So these red curved lines are the refraction lines, and the blue lines, the faded blue object there, that is giving a reference of how it would be without refraction. It would be like a symmetrical display or array of light, like this right here. You see that the top half and the bottom half are perfectly horizontally symmetrical. Okay, now if I turn on the refraction, you will see that this bottom portion gets smaller than the top portion, like that. So we're getting this lift. That is why we see the sun before actual sunrise. Okay, and we actually have sunset before the sun goes down. That is why this is happening, because of the glass concentric layers in the sky that are lifting the sun and the moon. And so this is the only reason why the selenelion can work. It's within the concave Earth
within the glass skies, and the bending light and the refraction involved. So if you go back, I'll show you the video I made about that a while ago, just holding up a glass bowl. You know, turn off the audio here. Let's get a bigger picture of that. And you will see how this happens. It's very simple to understand. See that? See the lift going on like that? It's not only lifting it, but it's squishing it as well. It's not only lifting it, the glass. That is why, that's the accurate reason, explanation why the sun gets lifted like that and squished, and the moon does as well. So the selenelion is finally accurately explained with the correct model of the universe, with the glass skies, with the concave Earth, with the bending light, and with the refraction involved. That's the only way you can get that significant amount of lift. So the observer's down here, and we're seeing the moon and the sun simultaneously, even though they are anti-solar. Okay, so see these top little half spheres? That would be if there was no refraction and they were perfectly anti-solar like that. But since we get the refraction from the concentric glass skies, it's going to lift it like that, and there's going to be an imbalance in symmetry horizontally from the bottom versus the top like that. So that's the same reason why from below the equator, say at 15, 20 degrees south latitude, you can see during, with a time-lapse photography that you see the star trails, you can actually see Polaris spinning like that because of the glass skies. That's the main reason. So it's solved. So this is unprecedented. You've never heard the reason why the selenelion happens. It's all happening because light is bending within the concave Earth. And there are glass skies. Who can make straight that which God has made bent? Thanks for watching.
You seen this graphic I made before? Wherever you are in the Earth, on the edge there, that's down. Center is up. There's an ether push that's pushing you perpendicularly to the edge of the Earth. You have a high voltage electrode on one side, and then you have a ground electrode on the other side. So sandwiched between that is the dielectric barrier and the discharge. So in my graphic, the dielectric barrier would be the glass sky, and the discharge would be the oxygen emitting the plasma, as you see here.
So we have the sun, high voltage electrode, the glass skies, the dielectric barrier, the oxygen plasma is the discharge, and then we have a ground electrode. So we have a beautiful capacitor going on here with the glass. The glass is creating the blue plasma. Now when it's red at the sunset or sunrise, I believe that the actual glass sky is is refracting the colors. Red, as I told you before in a previous video, red is the least refracted color, and so all the other colors get refracted away. So that's why we pick up the red. But the blue, I do believe it's because of the glass sky acting as a dielectric barrier that discharges the oxygen. You know, we have the ozone, right? The ozone layer, it's below the stratosphere. So that's why when we get up higher, the sky does not stay blue anymore. We're out of the oxygen zone. We're out of the ozone, okay? It's very simple, guys. Once you understand, we're living in the concave Earth, the concave stationary Earth. There's a glass sky that acts as a dielectric barrier, an insulator, which creates this plasma. It's very simple. That's why the sky is blue.
Seasons within the concave Earth. I animated the sun oscillating around the celestial sphere every 6 months. So when it's in the Tropic of Cancer, you'll notice that you get 24 hours of daylight at the North Pole and 24 hours of darkness on the South Pole. And conversely, when the sun is in the south, you'll see that you will get 24 hours of daylight on the South Pole and 24 hours of darkness on the North Pole. Originally, when I animated the sun, I did it linearly. There was no acceleration or deceleration, so I couldn't get the equinoxes to line up on March 21st or September 21st. However, when I added acceleration and deceleration, so it's decelerating at the extremes like that, the equinoxes lined up perfectly. And so in nature, you can conclude too that if something is orbiting around something magnetically and it's oscillating north and south like that, there's going to be acceleration and deceleration. In a heliocentric model, you have to conclude that the Earth is orbiting around the sun in an elliptical path. This is very unnatural. You also have to conclude that it's tilting. You have problems with that too as well. And you also have to conclude that it's precessing or wobbling, because it shows that after a year the sun is in a different location against the stars. But if you understand within the concave Earth, it's all taken care of simply by the fact that there's two different velocities. The velocity of the sun and the velocity of the celestial sphere, which is slightly faster than the sun. A sidereal year or a sidereal day is 4 minutes faster than the sun. So after a full year's time, the sun is simply just going to be 1/70th of a degree in a different location than the year before. The planets are all magnetically affected by the sun. So when the sun is inclined like that, the ecliptic of the planets, that magnetic ecliptic imaginary path, is going to be influenced by it as well. There's a real retrograde motion to the planet. It's not just an apparent retrograde motion caused by a supposed spinning Earth. It's simply the fact that when the planets go behind the celestial sphere opposite the sun, they're going to get confused magnetically. So they're going to go the other way for a little bit until they catch up with the sun's influence again, and then go the same way that they were going before. Mercury and Venus, they're going to be orbiting the sun. So when they go behind the sun, they're going to get confused as well. So that's how retrograde happens within the concave Earth. The Milky Way band, it's a band, it's not a spiral galaxy. It's actually a literal band that separates the celestial sphere into two different hemispheres, two different magnetically influenced hemispheres that actually steer the sun. So the Milky Way band has a function. So when the sun crosses that galactic plane every 6 months, it's also exhibited by the Ulysses satellite. They show that every 6 months the sun is oscillating back and forth. So when it crosses that plane, it steers the sun in the other direction. Like when it's up north like that, it's going to steer the sun south, and then conversely the same when it goes down south. When the sun goes down south, when it crosses that plane, it's going to steer the sun back up north. So it's all being influenced by that dividing line, that Milky Way dividing line. It has a purpose, it has a function. Everything works within the concave Earth. Sunlight is bending around the inside of the Earth. That's how we get lunar eclipses. There's an opposite funnel-shaped void area opposite the sun When the moon goes through that void area, it gets eclipsed. North or south of that void area, it's just simply going to be a full moon. So everything works in the concave Earth. You've seen my animation here, I made it a wide angle, so I wanted to include everything, so that's why it kind of looks kind of funky, but it's Occam's razor. The simplest answer is always the best answer, so.